Mr. Samuels here with a discussion of thermochemistry. But first, two hydrogen atoms bumped into each other recently. One said, "Why do you look so sad?" The other responded, "I lost an electron." Concerned, one asked, "Are you sure?" The other replied, "I'm positive." Get it? Okay. So let's talk about thermochemistry. Thermo obviously having to do with heat or temperature. Chemistry is the study of matter. So let's examine when two objects or samples of matter at different temperatures come in contact, what happens. You can experience this by putting your hand on the desk. What do you feel? Well, you should feel the desk seems cold. Now let's think about what's happening there. Is the cold going into your hand? Or does it make more sense to say that the desk is pulling heat out of your hand? We'll leave it there for a minute, and you'll notice eventually it stops feeling cold. And that's because we don't really sense temperature. We sense the movement of heat. Eventually, your hand and the desk will be at the same temperature, so that heat won't flow, it won't feel cold. But if you remove your hand, you can feel that spot being warmer than the rest. This is the exact same thing that happens when you get into a cold pool. The cold is not going into your body. The heat is being lost from your body into the pool. Eventually, the temperature of your skin cools down and it doesn't feel quite as cold anymore. Let's watch a little video clip to help understand that.
Molecules of a hot substance move more rapidly than those of the same substance with a lower temperature. If the two samples come in contact, a transfer of molecular momentum occurs from the rapidly moving molecules to the slower ones. In this way, thermal energy transfers from the hotter sample to the cooler one. When the two samples have similar rates of molecular motion, they have reached thermal equilibrium and have the same temperature.
Okay, so we've got some fancy terms in that video, but hopefully you understood. The molecules basically bump into each other until they're all moving on average at the same speed. So heat actually takes a symbol capital Q when you use it in an equation, because capital H is used for something else we'll discuss later. But remember, it's a form of kinetic energy. That's different than temperature, so it's got different units. Calories are a commonly used unit of heat, and by definition, a calorie is how much energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius. So if you want to raise it 2 degrees Celsius, it's going to take 2 calories. If you want to heat up more water, it takes more energy. Specific heat capacity is another quantity, like density, that is specific to a substance. It's defined as the amount of heat required to raise 1 gram of a substance by 1 degree Celsius. So you guys just learned the specific heat of water. We said a calorie was how much heat it takes to raise a gram of water by 1 degree. Well, then the specific heat of water will have units kind of like this, but a value of 1. 1 calorie per gram degree C, or if you remember with our conversion to joules, 4.18 joules per gram degree C would be the specific heat capacity of water. So this is the only one you need to memorize. All the other substances, the specific heat will be given, or you can calculate it given other variables. Let's look at the equation that connects all these things. Q equals mCp delta T. I'd like you to write a little arrow for each one defining each of these terms. So write an arrow here and write, well, what would you write? Remember, what was Q? Heat. That's right. M stands for mass, Cp, specific heat capacity. And this triangle symbol is a Greek letter delta. It means change. So this is one variable here. It means change in temperature. Okay? Q equals mCp delta T. You can even put it in rhythm. Q equals mCp delta T. So let's use this equation in an example. How much heat is required to raise the temperature of a 25-gram sample of water by 2 degrees Celsius? Write this in your notes. What I like to do with these kind of problems is look at the equation that connects them, or just make a list. You can write grams. Let's see, what would that be? Oh, that's mass. So m equals 25 grams. Write that down. Degrees Celsius is a unit of temperature. Oh, and that's how much it's raising by. If they give you two temperatures, you just subtract. But at any rate, delta T equals 2 degrees C. And since we know that it's water, we know the CP. You can write CP equals 1 calorie over gram degree C. And I like to put a question mark with the variable we're trying to find. Let's see, what is it asking for? Oh yes, heat. So I would also write on that list that you wrote, Q equals question mark. Then you write the equation with no numbers, just the raw form, so I know which equation you used when I correct your work. And then just put a parentheses for each variable. Kind of like this. You just plug in each one. The mass is 25 grams, specific heat is 1 calorie per gram degree Celsius, and the temperature change is 2 degrees C. Rewind this and listen again if you need another explanation. But basically what's going to happen is once you cancel your units, grams on top, grams on bottom, because this is a fraction. Celsius on top, Celsius on bottom. You can actually probably put the gram degree C under here. It might be more appropriate. It'll be easier to see what's going on. But what you'll see is the only thing that didn't cancel was calories. And that's right, folks. Calories is a unit of heat, so that makes sense. It's going to take 50 calories to heat up that much water by 2 degrees Celsius. And that kind of makes sense because it's not a ton of water. It's not heating up a whole lot, so it doesn't take a ton of energy. Let's do a practice problem now. Go ahead and pause the video. Make a list when you do this problem to find how much heat is required to raise the temperature of a 15-gram sample of water by 3 degrees Celsius. Okay, go ahead and pause now. Make your list. Write the equation. Plug and solve. Okay, once you're done, you should have come up with, and you should have the list here on the side. Sorry, you don't see it here. But once you cancel all your units, you should end up with 45 calories. And that makes sense. It's a little less water than last time. So even though we're heating it up 1 more degree, it's not going to take quite as much energy. Okay, let's do another practice problem. This time it's not with water. They gave you the heat capacity, so put that on your list. CP equals. Make the rest of your list. And if you have to convert something, you might need to do some unit analysis on the side. Hint, hint, kilograms. Okay, so hopefully you paused it and worked this out, and at least gave it a shot. Again, make your list. I'm sorry it's not present in the slides here. But you should, on that list, when I put 0.34 kilograms, I, on that list, like to throw in that conversion, a one-step unit analysis to get that into regular grams. And then once you do, remembering there's 1,000 grams per kilogram, you get this is equal to 340 grams. Why did I convert to grams? Well, remember, the grams have to cancel. If you have kilograms here and grams here, you're going to be about 1,000 times off in your answer. You don't want that. And so when all is said and done, you should come out with about 98.9 calories to heat up that much air. Okay, oh, and actually, a little special thing here. That was actually the classroom. I did the mathematics to figure out how much air, did the unit analysis to figure out how much air was in the room, and that's actually how much energy it takes to heat up the room 1 degree. Now, a little side note, remember when we talked about conservation of energy, it has to come somewhere. So if you ran on a treadmill for, I don't know, maybe, might take you like 10 minutes to burn this many calories, you would heat up the temperature of the room 1 degree. Interesting, eh? All right, let's do another example here. Copy this one in your notes. Calculate the specific heat of a substance if 75 joules increases the temperature of a 150 gram sample by 2 degrees Celsius. Now this time we're not trying to find Q. This is specific heat capacity, CP. So your list is going to look a little different. Where's the Q that we're going to plug in? Ah, here we go. 75 joules. Joules is a unit of energy, so that's your heat. This time we got to do a little algebra. If you divide both sides by m and delta p, or I'm sorry, m and delta t, you get CP by itself. Write that form of the equation. Show the work. Now what you'll notice here is when you plug everything in, nothing cancels. But that actually makes sense. Because if we're trying to find specific heat, we're going to need some pretty wacky units like joules per gram degrees C. All right, let's do one more practice problem here. Calculate the specific heat of an unknown substance if 155 calories increases the temperature of a 14-gram sample from 12 to 28 degrees C. Now remember, delta T is the temperature change. So to get delta T here, you're going to have to, that's right, subtract. All right. Well, good luck on your practice problem. We'll go over that one in class.